So if you're going to be changing a number in the decimal system to binary system, we're going to take a look at two different ways of doing that. Our first example is 35. So we have 35 to the base 10, because that's what binary is. So how would I write that in binary, which is to the base 2? Now we remember that we have our columns. So the columns for binary are 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, so on. You go on. Now if I write those without the exponents, that would be 1, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, and 2 to the 5 is 32. So these are the columns. Now, I know that 35 can be broken down. It can be written as 32 plus 2 plus 1. And I could then directly convert it from that, because here's my 32 column. Well, I have 132. Here's my 2 column here, so I have 1 there. And here's my 1s column. And the 16, 8, and 4 column, I place zeros. So that means that 35 to the base 10 could be written as 1, 0, 0, 0, 1, 1 to the base 2. That's one way of doing it. It's an intuitive way of doing it. But when you get to bigger numbers, it's a little bit difficult to do. There's a lot going on. So instead, there's a division method, which I'm going to go over here. So for the division method, I take my number, and I'm going to divide this number by 2, and I'm going to keep on dividing it by 2. Okay. Now, if it divides, this is an even number, it has no remainder, then I'm going to write a 0 here. So this is the remainder. And then I'm going to keep on doing that down here. So 156 divided by 2 is 78. It's even again, so no remainder. Divide that by 2, I get 39. Now if I divide 39 by 2, there is a remainder of 1, so I'm going to write that here. So if I now have 38, I divide 38 by 2, I get 19. That's an odd number, so I have a remainder. Now 19 minus 1 is 18. 18 divided by 2 is 9. Now that's odd, so it has a remainder. So we take away 1. 8 divided by 2 is 4, which is even. So there's no remainder. 4 divided by 2 is 2, which is even. 2 divided by 2 is 1. And 1, of course, has a remainder. Okay. So, to read this, since it's a little less intuitive than this approach, you need to remember that this is what they call the MSB, the most significant bit. So this is the most significant bit, and it goes down to the least significant bit. So that means when you write this horizontally, like we usually write numbers, that's going to look like 1, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0 to the base 2, and that is equal to 156 to the base 10.